हेलो बच्चियों, इस एपीसोड ਵਿੱਚ ਤੁਸੀਂ ਸਰਕੂਲਰ ਪਰਮਿਊਟੇਸ਼ਨ ਅਤੇ ਕੰਬੀਨੇਸ਼ਨ ਦੀ ਵਰਤੋਂ ਬਾਰੇ ਸਿੱਖੋਗੇ। ਤੁਹਾਨੂੰ ਪਹਿਲਾਂ ਤੋਂ ਹੀ ਇਹਨਾਂ ਬਾਰੇ ਜ਼ਰੂਰ ਜਾਣਕਾਰੀ ਹੋਵੇਗੀ। ਫੈਕਟੋਰੀਅਲ ਨੋਟੇਸ਼ਨ, एफपीसी यानी फंडामेंटल प्रिंसिपल ऑफ काउंटिंग, नंबर ऑफ परम्यूटेशंस ऑफ डिफरेंट ऑब्जेक्ट्स टेकन ऑल एट ए टाइम, नंबर ऑफ परम्यूटेशंस ऑफ n objects taken r objects at a time, permutations of repeated objects ਅਤੇ introduction to circular permutation। ਤੁਸੀਂ ਪਹਿਲਾਂ ਹੀ ਸਰਕੂਲਰ ਪਰਮਿਊਟੇਸ਼ਨ ਬਾਰੇ ਪੜ੍ਹ ਚੁੱਕੇ ਹੋ। ਆਓ ਹੁਣ ਇਸ ਦੀ ਵਰਤੋਂ ਵੇਖੀਏ।
When things are arranged in places along a line with first and last place, they form a linear permutation. So far, we have dealt only with linear permutations. When things are arranged in places along a closed curve or a circle in which any place may be regarded as first or last place, they form a circular permutation. The permutation in a row or along a line has a beginning and an end. But there is nothing like beginning or end or first and last in a circular permutation. In circular permutations, we consider one of the objects as fixed and the remaining objects are arranged as in linear permutation. Each circular permutation corresponds to n linear permutations depending on where we start. Since there are exactly r factorial linear permutations, there are exactly n factorial upon n permutations. Hence, the number of circular permutations is the same as n minus 1 whole factorial. Suppose we have two blocks A and B to arrange on the floor. You could arrange them either in the order AB or BA. Since permutation depends on the order of the elements, these two arrangements represent the different permutations of two blocks. On the contrary, if you do not take care of the order in which the blocks are arranged and we only consider the selected elements, then we say that these arrangements represent the same combination. Therefore, combination can be defined as unordered collection of distinct elements. Consider the case of choosing two balls out of 3 available balls. There are total 6 permutations when we select 2 balls from the 3. Also, the chosen set of 2 balls can be arranged in 2 factorial different ways. On the other hand, each such set represents the same combination. Since 2 factorial permutations represent one combination, total permutations divided by number of permutations representing one combination, that is 2 factorial gives total number of combinations. In general, we can say that the number of combinations of n different things taken are at a time denoted by NCR equal to NPR upon R factorial, or it is equal to n factorial upon R factorial into n minus R whole factorial.
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਸਰਕੂਲਰ ਪਰਮੂਟੇਸ਼ਨ ਅਤੇ ਕੰਬੀਨੇਸ਼ਨ ਦੀ ਵਰਤੋਂ ਬਾਰੇ ਸਿੱਖਿਆ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਉਦਾਹਰਨਾਂ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see an example. A round table conference is to be held between 20 delegates of 2 countries. In how many ways can they be seated if 2 particular delegates are always together or never together? Now its solution. So first, when 2 particular delegates to be seated always together, so the number of ways in which 2 particular delegates sit is equal to 2 factorial, and the number of ways in which remaining 18 delegates can sit is equal to 18 factorial. Now, by fundamental principle of counting, total number of ways in which 20 delegates be seated such that 2 particular delegates are always together is equal to 2 factorial into 18 factorial ways, that is equal to 2 into 18 factorial ways. Now, 2 particular delegates never sit together number of ways in which 19 delegates be seated after one delegate be seated at a particular place is equal to 19 factorial, and we know that number of ways in which two particular delegates are always together is 2 into 18 factorial. So therefore, total number of ways in which 20 delegates be seated such that two particular delegates are never together is equal to 19 factorial minus 2 into 18 factorial, that is equal to 19 into 18 factorial minus 2 into 18 factorial, which is further equal to 19 minus 2 into 18 factorial is equal to 17 into 18 factorial ways जो कि ਅਸੀਂ पता करना है। Now let's hear another example. There are 5 gentlemen and 4 ladies to dine at a round table. In how many ways can they sit themselves so that no two ladies are together? Now its solution. Total number of gentlemen is 5. Total number of ladies is 4. So there are total 9 places for no two ladies to be seated together a gentleman has to be sit between every two ladies so the number of ways in which 4 ladies be seated is 5p4, because 4 ladies can take any 5 of these seats, and that is equal to 5 factorial upon 5 minus 4 factorial is equal to 5 factorial upon 1 factorial is equal to 5 factorial ways. So the 4 ladies can be seated in 5 factorial ways. Now the number of ways in which 5 gentlemen can sit so that no 2 ladies are together is 5 minus 1 factorial ways, that is 4 factorial ways. Therefore, the total number of ways in which 5 gentlemen and 4 ladies sit so that no 2 ladies are together is equal to 4 factorial into 5 factorial that we get by using fundamental principle of counting. That is further equal to 4 into 3 into 2 into 1 all multiplied by 5 into 4 into 3 into 2 into 1, that is equal to 24 into 120, which is equal to 2880 ways. So the total number of ways in which 5 gentlemen and 4 ladies can sit in a round table so that no 2 ladies are together is 2880 ways. जो कि ਅਸੀਂ पता करना ਸੀ. Now let's hear another example. 3 boys and 3 girls are to be seated around a table in a circle. Among them, the boy X does not want any girl neighbor and the girl Y does not want any boy neighbor. Then, how many such arrangements are possible? Now its solution. Total number of boys is 3 and total number of girls is also 3. Let B1, B2 and X be 3 boys and G1, G2 and Y be three girls since the boy X does not want any girl neighbor, therefore the boy X will have his neighbors as boy B1 and boy B2, since the girl Y does not want any boy neighbor, therefore the girl Y will have her neighbors as G1 and G2, now boy B1 and B2 can arrange themselves in 2 factorial ways, and girls G1 and G2 can arrange themselves also in 2 factorial ways, therefore the required number of arrangements is 2 factorial into 2 factorial is equal to 2 into 1 into 2 into 1, that is equal to 4 ways. So the required number of arrangements is 4 ways as shown. In the first case, boy X can sit B1 on the left side and B2 on the right side of his. In the first case, the boy X can sit as B1 on the left side and B2 on the right side of him, and the girl Y can sit the girl G1 on the left side and girl G2 of the right side of hers. In the second case, the boy X can sit the boy B1 on the left side and boy B2 on the right side of him, and the girl Y can sit as the girl G2 on the left side and the girl G1 on the right side of hers. In the third case, the boy X can sit as the boy B2 on the left side and boy B1 on the right side of him, and the girl Y can sit as the girl G1 on the left side and girl G2 on the right side of hers. In the fourth case, the boy X can sit as the boy B2 on the left side and boy B1 on the right side of him, and the girl Y can sit as the girl G2 on the left side and girl G1 on the right side of hers, जो कि ਅਸੀਂ पता करना ਸੀ।
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਸਰਕੂਲਰ ਪਰਮੂਟੇਸ਼ਨ ਅਤੇ ਕੰਬੀਨੇਸ਼ਨ ਦੀ ਵਰਤੋਂ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਉਦਾਹਰਨਾਂ ਨੂੰ ਹੱਲ ਕੀਤਾ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਹੋਰ ਉਦਾਹਰਨਾਂ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see another example. Find the number of ways in which 8 different flowers can be strung to form a garland so that 4 particular flowers are never separated. Now its solution. Total number of flowers is 8. Now number of ways of arrangements so that 4 particular flowers are never separated is 4 factorial ways, as these 4 flowers can be arranged in 4 factorial ways. Now number of ways of arrangement of remaining 4 flowers is 4 factorial. Now by fundamental principle of counting, total number of ways of arrangements so that 4 flowers are never separated is 4 factorial into 4 factorial, that is equal to 4 into 3 into 2 into 1 into 4 into 3 into 2 into 1, that is equal to 24 into 24 equal to 576 ways. जो कि ਅਸੀਂ पता करना ਸੀ। Now let's see another example. If NPR is equal to 720 and NCR is equal to 120, then find the value of R. Now its solution. As we know that NCR is equal to NPR upon R factorial. Now putting the values of NPR and NCR, we get 120 is equal to 720 upon R factorial, implies that R factorial is equal to 720 upon 120, on solving. It is equal to 6. So it implies that r factorial is equal to 6. It can be written as it is equal to 3 into 2 into 1. So this implies r factorial is equal to 3 factorial. Implies that r is equal to 3. Therefore, for the given example, the value of r is 3, जो कि ਅਸੀਂ पता करना है। इस एपिसोड विच तुसी सिक्ख्या है Applications of circular permutation. A combination is defined as an unordered collection of distinct elements. Number of combinations of n different things taken are at a time is n factorial upon r factorial into n minus r whole factorial for r greater than 0 or less than equal to n.
इस एपीसोड ਵਿੱਚ ਤੁਸੀਂ ਸਰਕੂਲਰ ਪਰਮਿਊਟੇਸ਼ਨ ਅਤੇ ਕੰਬੀਨੇਸ਼ਨ ਬਾਰੇ ਸਿੱਖਿਆ ਹੈ। ਉਮੀਦ ਕਰਦਾ ਹਾਂ ਤੁਹਾਨੂੰ ਐਪੀਸੋਡ ਪੂਰੀ ਤਰ੍ਹਾਂ ਸਮਝ ਆ ਗਿਆ ਹੋਵੇਗਾ। ਧੰਨਵਾਦ।